Hi. Hello, everyone. I'm just waiting for everyone's got set up, and we're going to start in a few minutes, okay? So, my name is Ítalo. I'm a software engineer from Brazil. It's nice to meet you all. I'm going to be your host today for this tutorial, going beyond with Jupyter Notebooks. I'm going to present to you the Nbdev library. I'm pretty nervous and excited because it's my first PyCon, and it's my first tutorial as well, presenting here. Nbdev is the library we're going to discuss today, and it got in a GitHub program, and it will be accelerated. So its development, it will get way better. So I'm a software engineer from Brazil. This is where I live. This city is called Natal. It was a big shift of weather. I'm a computer scientist, almost there because I'm working on my thesis right now. I work as a researcher in development using Python. And I'm also an open source maintainer. I'm also a contributor for Python community in my city. And today we're going to discuss a lot of things. So we're going to introduce the concepts to publish a package and why we're going to need to publish a package, discuss Python packaging system and distribution, explain the concept of literate programming, show how Jupyter Notebooks works, introduce the Nbdev library and how we can use to program using this programming paradigm called literate programming, explain good practices, and develop a minigame with a French deck library. I'm going to display how to use the quality assurance on Jupyter Notebooks, discuss how we're going to test our software, show how to publish a Python package, introduce GitHub Action to use CI/CD, talk about a little bit about Python packaging past and future, introduce how to build UIs for Jupyter Notebooks, show why is Quartal, what's Quartal, and how to customize it, and demonstrate how to use ChatGPT in Jupyter Notebooks. So if you have any question, you can just raise your hand, or if we're gonna run some exercises during this tutorial. If you having trouble with the exercises, just raise your hand. I'm gonna be at your desk. So let's introduce some core concepts of Python packagings. There are two main concepts that are modules and packagings. Modules are files that contains Python code, Python definitions, statements. Any Python file can be considered a module. So in this code right here, we have this module.py. This write file, it's a magic cell that writes a file in Jupyter Notebooks. And we have just a simple function called hello that will print a hello. So going beyond, modules can be executed as Python scripts, as a regular Python script. If you're running in your interpreter this module.py, and you have this conditional name equals main, you're gonna see that it will run the main code that's inside this conditional. And how Python interpreter looks for the modules when you open your interpreter. So let me show you here. When you open your interpreter, you can import the sys module, and you can get this modules.names right here. This is all Python building modules. So Python first loads all these modules, and you can call and use them, or it will look at the sys.path. So here are my files where Python is looking at my modules, okay? So that's how Python search for modules when you're loading things on your packaging on your Python structure. The main concept here is packages. That's a collection of modules, right? So it uses .modules name. For example, when you're using this from my package, some module, import, some function. This is what they call dotted module names, okay? So now we're gonna start our first exercise. This folder structure here, you can create on your computer this some folder structure. With this username, you can switch your username by your GitHub username, underline package, and write these files. You don't need to write code now. Just open your terminal and create this folder structure, right? Can you see this folder structure? Okay, let me show you.
Probably can't tell, but the contrast is impossible to read from the screen.
Okay, I'm just gonna exclude some things here, and you're gonna be able to see the folder structure. Oh, okay. You can see, you can still don't see, right?
Can you change the background color?
Yeah. Not sure if it helps. This one? Okay, so you create a folder. You can call whatever you want. And you're gonna add this init module in here and the module.py is the main folders and files that you need. What?
Just 2 files?
Yeah, you're gonna create the folder and these 2 files. You can ignore the remaining. Everyone was set up already? Okay. We're gonna first publish this small package just to understand how to publish, package, and distribute it. And later we're gonna use Nbdev and Jupyter Notebooks to distribute a more fancy package. I suggest you use these inside the folder that you created. You need to create, this is something that I should explain before. You should create a folder with your GitHub name underline package, because we're gonna publish this package on your TestPipeI account, okay? So create your username package inside of your folder with these two files right here. Let me show you. Okay, so you're gonna access a folder like examples right here, and you're gonna create another folder with your GitHub username /package, and then you're gonna create these two files, empty files, .init.py and module1.py. No, it's the main thing, is the exercise. Yeah. With examples? Sure. Like you have this, okay. Like you create your username package. No, yeah, you're gonna put somewhere in your computer, so it's some folder, you can name it whatever you want. Okay. Everyone was able to create a package with your GitHub username /package and these two files inside that package. Okay, let's move on. So you can open your terminal, your Python terminal, and you can import those files like from your username package. Fix here. So you're gonna be able to see that the Python interpreter is searching for your Python files that is loaded in the current folder. I'm here using examples. You're probably put somewhere in your computer, so you're gonna be at this file and run your interpreter there. And you're gonna be able to import your package. Everyone was able to import your packages? Okay, so if you go to a different folder and try to load your Python interpreter and load your package, you're gonna see an error. Mine is not throwing an error because I installed this package before, but it probably show a package error. It can find that package. But if you're using import sys and append your folder, some folder on your computer, you're gonna be able to import your package. So have you be able to see the error when you throw? So import sys, append your folder name right here, and you're gonna be able to import your package. This is an workaround that some people uses. You can see, okay. Okay, so everyone is already completed the task? Great. I'm sorry about that. I thought that this folder structure would be easier to read. So with this exercise, we understand how Python can import things and how they load our modules and understand our packages, right? Python packaging searches like the Python modules. It uses the sys.path as well. When you're appending something to that path, you're adding a path that's not usually add to your Python. This is a workaround. It's not recommended to use this append right here, but it's something that you can see in some code and some Python packages, so be aware it's not a good practice, but it's to understand how Python loads its modules, okay? So why packaging? Why do we need to share a piece of code with others and publish that Python packaging? I like this example. I'm not sure if you can see down there. We have this Avenger movie, Avenger 1 and Avenger 2, where the Avenger 1, we have a full application called Avengers with 3 heroes right here, Hulk, Black Widow, and Thor. And okay, we run our application, we run the Avenger 1 application, and it's like a monolith, is everything there. But then we need to build Avenger 2 and to share that multiple heroes in different timelines for other movies. So a good way to do that is create a package for every superhero. So this is an example for modular architecture in Python packaging, a talk from Python Brazil in 2022. I found a great example to show how we normally use Python packaging in a Python code. So the pros of using Python packages is it increases the code reuse. You're going to be able to import that Hulk, that Black Widow packages. It reduces the coupling because the superheroes, it will not talk with each other. So the coupling between those files, it will not exist. It will be easier to maintain, easier to other developers to use. It will split the responsibility across teams. If you're having a big team that's working on one application, you can split in multiple Python packages and make it easier to run faster. But there's some problems as well. So when you're writing Python packages, you have the version of your package, and managing multiple packages on an application can be difficult. If you're not developing the Python package that you're installing, you can't guarantee your security. And packages sometimes have more features than is needed for your Python application, okay? So we have a minimal example of a Python package on your computer, how we can build that package and distribute that package so anyone can download that package. We need to create, okay. Okay. Yeah, it's related. Because, for example, sometimes there's a concept called dependency hell. That's where you have like this hook application runs Python 3.0. It's called dependency hell. It's when you have, when you have conflicts between the versions of your software. Like Hook requires a version of Python, and Thor needs a different version of Python. So it conflicts. You can't move your application forward because there's a conflict between those two packages. This is a dummy example, but okay. So when we're gonna distribute our package, we need to add the name of the package and the version. We use usually a setup.py or a more new approach using pyproject.tom. We build our project using a source distribution Python packages or a binary Python packages, okay? We're gonna discuss this later. And using this backend, it will produce an artifact. It's a file that is stored or this weird format will. And after building our package, we're gonna upload that to some place that can distribute our package. So we usually use PyPI or test PyPI. That's more common in the Python community to use them. But I will show you some other packages where you can publish and distribute your package. Okay? So what is PyPI? It's the Python package index. It's where most of the Python packages you install and use on your computer is hosted. So when you're using pip, it's downloading the package from the PyPI index, okay? And the PyPI contains a lot of Python packages and has multiple problems of, like, it's a big repository and scale that is very difficult. So they have this test PyPI that's a separated index for learning. And we're gonna use the test PyPI for publish our minimal package that we just created now. So I will ask you to create an account on test PyPI right now, if you don't already have one.
Are you going to show this presentation?
Yeah, so it's on my GitHub. You can access. Like my GitHub is Ítalo Epifânio, and the name of the application is going beyond with Jupyter Notebooks. Maybe searching, you're gonna find. Let me. You will stay, yeah. You will all fork this repository later on this tutorial. So you're gonna have a version on your own. So test PyPI. Ooh. I'm sorry, you can't see, but test PyPI is this site right here. You can register or log in if you already have an account. I'll give you about 5 minutes to create your account, okay? After you created your Python packages, you may need to activate your account, okay? So go to your email and activate your account as well. So is everyone okay with your account? Okay, let's move on. Now that we already have our test PyPI account, we're gonna publish those files that we created before. So go to some folder that you create on your computer and create a setup.py file with this content right here that you may not be able to see, but I'm gonna add it here. Can you see, you guys? Okay. So you're gonna create a setup.py on the root of some folder you create on your computer, and add this to your setup.py. Okay. instead of the username, you're gonna use your GitHub username, the package you created right here, the name, okay? Like, okay. Everyone just, okay. So your folder should look like this. Now you have your package, right? And you have your setup.py with that content we just write. Now we can create a virtual env. You're gonna enter your folder and type Python. Let's m the virtual environment module you're gonna load, and create a virtual environment name. I'm gonna name example right here. After you create this, you're gonna be able to load using this command. Have you everyone be able to create your virtual environment? You may need to install virtual environment if you don't have installed on your computer, okay? After that, activate using the source, the name of your virtual environment, and activate. You can press enter, and it will activate your virtual environment. Has everyone been able to activate your virtual environment? No? Okay, with your virtual environment activated, you can install Twine. It's a package that will help us to distribute our package. It's gonna publish our package on test.py. Okay, so if you're using Windows instead of using source, you're gonna go to the file that we created, like it's gonna create an activate script somewhere in your computer, and you can just type enter if you're using Windows. It's activated, right? Okay. We're using virtual environments to avoid to mess up with our global environment, right? It's a way to isolate our environments. Okay. Has everyone been able to install Twine? Oh, okay. So now that we already have Twine installed or our package set up, we can execute this to build our Python package. It will create a source distribution of Python, like Python regular code, and a binary distribution using wheels. That's another format. We're gonna distribute our packages in these two ways. There are the ways of your distributing your packages. So you can run this, you're gonna see that it will create a dist environment with 2 files there. No, you can do that too. You can do the two of them together. So if you're using Windows, you can just ignore the wheel part and build this. Okay. So has everyone been able to build your package? Now we're gonna upload our package on test.py. It's the final step. We're almost there. Okay. So we're gonna use Twine to upload on test.py using this command. We're gonna be able to type your email and password and upload your package to test.py. Yeah, it should work on both. Okay, so if you already upload your Twine package to your test.py account, you can check your test.py account and see the package there. You'll be able to install, and everyone in the room will be able to install your package as well. It's your username from your test.py account. Guys, we're running out of time, so I will need to move on with the tutorial without this exercise. Outside of the tutorial, we can talk and see the errors, okay? Sorry about that. I thought it would be easier to upload those packages and understand how Python understands these core concepts, okay? So we uploaded to PyPI, or should have uploaded to PyPI, but there's other servers where we can upload our packages. Like PyPI server, you can run locally or self-hosted, JFrog, AWS, Code Artifacts, Google Artifact Registry, GitLab also has a registration of Python packages. And GitHub, I didn't find a way to upload Python packages to GitHub, but they also have a package registration for Ruby and for Node, okay? Let's introduce now the concept of literate programming. That's a way to tell a story with your code. It was introduced in 1984 by Donald Knuth. If you're in computer science, you already know Donald Knuth. He's published a lot of important papers in computer science. In these papers, he said, let us change our traditional attitude to the construction of programs. Instead of imagining that our main task is to instruct a computer what to do, let us concentrate rather on explaining to humans being what we want a computer to do. So this concept mixes code and markdown, or code and human literature into computer programs. Haskell is one of the languages that brought this into its core development. So if you're writing a Haskell program, you're using this .8s. And if you're using literate programming with Haskell, you're using L8s. And you're able to write code and write human language like Spanish, like English. You can write and tell a story with your code. Its literate programming usage increased in the last years. So data science has grew a lot in the past years, and the literate programming grew with the data science field. And the most used tools are Jupyter Notebooks and RStudio for literate programming. So introducing, you may not be able to see the image. Yeah. So this is how Donald Knuth thinks of literate programming. He created a language, a script called Web, where you can mix code and mix text. And it generates a text file or a Pascal binary file. This was in 1984, okay? So using Jupyter Notebooks, we write a Jupyter Notebook, and we use Quarto. That's a software to write markdown files. and use them as PDF, HTML, like publish our documentation. And we use this library called Nbdev to generate Python codes. So from the Jupyter Notebook code you wrote, you generate your documentation and your Python scripts that's gonna be used for publishing Python packages, okay? So I will introduce very quickly Jupyter Notebooks. If you can type pip install notebook to install Jupyter Notebook, and type Jupyter Notebooks on your terminal. I'm not gonna wait for you guys because we're very late. So I'm gonna show you the page. This is the UI that Jupyter Notebook runs when you open it. I'm create a simple new Jupyter Notebook. When you're creating a Jupyter Notebook, you give to the file a name. Later, you can mix this field right here is called cell. You can change a cell to code or markdown. So we usually start our Jupyter Notebooks writing a title to the Jupyter Notebook and a simple description of what your Jupyter Notebook is doing. Then we can write Python code, and we can mix the two of the text and the Python code in a Jupyter Notebook, and we can test it like it's not a linear thing, it's not sequential. You can like have a counter right here and increase the counter. And like counter now is 1 because it's sum, but you can run like this multiple times and have the answer. So you can experiment a lot with Python code in Jupyter Notebooks. But when you're creating a Jupyter Notebook, you expect that the Jupyter Notebook will run smoothly to the end in a sequential way. So you can experiment as well as the way you want, but you need to run everything sequentially at the end. So to run a cell, you can use this run right here. Are you able to see? So you have this button here to run. You have like, you can move the cells. You can change the type of your cell. Code Markdown is more used, but you also have other different types that we're gonna discuss later. If you like to use shortcuts, all shortcuts of Jupyter Notebooks are listed here, okay? This would be an exercise to create a Jupyter Notebooks. Do you want to have about 5 minutes to try Jupyter Notebooks and its interface? Okay, let's move on. So there's a different, this is the traditional UI for Jupyter Notebooks. It's called Notebook Classic. But the most popular one is Jupyter Lab. We're not gonna use for this tutorial because Jupyter Lab has more features that we want to use today. When you create a Jupyter Notebook file, it will create a file with this format IPyNB. IPyNB stores, like you can see very well, but it's a JSON file. IPy notebooks or JSON files are stored like that. And as you can see, the code is here, and the output of that code is also added here to the Jupyter Notebook. So once you run your notebook, he will keep the history of your running. After Jupyter Notebook introduction, let's get to the main concept of this tutorial. That's Nbdev. It's a library that allows you to publish Python packaging, just like the publishment that we made previously. Jupyter Notebooks using Nbdev allows you to use GitHub Actions to publish and to run your Jupyter Notebooks. You're gonna have a documentation from your Jupyter Notebook using this Quarto software. You'll be able to upload your deck on PyPI or test PyPI, and you'll also be able to upload your package to the Anaconda repository. That's another repository where you can store your packages. So this is the part that you will fork my repository. Let me add to the terminal. You can fork this repository just to have on your machine, and you'll be able to use as a consultant a material later. We're not gonna run this exercise, but it will help you to have this material later. So please go to this URL and fork the repository, please. It's outside in some other place than you create the previous. We will ignore the previously created tutorial, the previous created project. So you're gonna access this repository right here, and you're gonna click on fork right here. We're forking because later we're gonna publish these packages using GitHub Actions, okay? So, okay, after forking the repository, we're gonna do some exercise later if we have time. But I want to show you how Nbdev distributes its folders and its structure and how it's working, how it works. So when you create an Nbdev project, it will create this NBS folder where you will store all the Jupyter Notebooks, and we'll also create some metadata files like Nbdev IML. The NBS folder, it will be created. It will create as well a GitHub workflow with the workflows that you need to use with GitHub Actions, okay? And we'll create this settings.ini. If you uploaded your package to test PyPI, you're gonna see that is missing a lot of information. That's because it was a minimal example. But when you're using Nbdev, all metadata is available here in settings.ini. So your name, the description of the package, the version, everything's there. And it also creates this setup.py. That's a more fancy setup.py with licensing and everything and requirements. So here on my settings.ini, I created a package, a French deck package, that doesn't have any requirement, like you're gonna install only the French deck package, but it has a lot of dev requirements. So it has some QA tools, some test tools, some things that I'm gonna explain in later, okay? So this is what Nbdev creates on your machine when you created an Nbdev package. Let me show here how to execute. Like when you install Nbdev, it's a CLI tool. So it has a lot of features, but the main features of Nbdev, it's cleaning your Jupyter Notebooks, because when you run your Jupyter Notebooks, all metadata is stored there. And when you're uploading your Jupyter Notebooks to GitHub, you want them clean and without those outputs. You also have the Nbdev docs that create your documentation from your Jupyter Notebooks. Nbdev export that export your Python packages from and the Jupyter Notebooks. Nbdev install hooks for a Git-friendly usage of Nbdev. Like if you have Git conflicts with your Jupyter Notebooks, Nbdev will handle that for you. Nbdev install Quartal. If you doesn't have Quartal on your computer, you can install using their CLI. Nbdev PyPI to upload to PyPI, Nbdev Conda to upload to Conda, and Nbdev Prepare Nbdev both. That's somewhere here. That will upload it on Conda, yeah, Nbdev release both. That will upload on Conda and PyPI. So Nbdev is a CLI tool. When you have your Jupyter Notebooks, it will be able to export as a code and a Python package. So when you have a Jupyter Notebooks, you're using Nbdev magic comments to create your Python packaging. For example, this is a Jupyter Notebook that uses Nbdev. This default exp, it says the name of my file, that's core. I'm describing the module that I'm developing here. It's a deck, a French deck module inspired by Fluent Python book. You're exporting your imports. This will be added to the core file. You're hiding this from the documentation. So the hide is used, like if you don't need to export your imports to the documentation, you can hide them. So I'm explaining some features from the core. It's a module. Let me run here. So I'm creating a core file. I'm exporting this to my file. I'm hiding this from the documentation. And I'm exporting the card definition. It's a card that contains a rank and a suite property, okay? I'm executing this example on my documentation. So this output right here will be added to my documentation. I'm explaining the French deck and how it works right here. Yeah, so export I, the difference is because export I, it will gonna export without the API. Let me show you. I will show the exported code. So this is the core file that will be exported from the Jupyter Notebook. So you will be able to see the exports right here. But if I run my documentation, it will not be able to see there. Like this is my deck. This is the documentation generated from the Jupyter Notebooks. So it has the title, the description. I'm exporting the imports, but it's not in the documentation. And like from this example, this is something I'm running on the Jupyter Notebooks, but it's not necessarily on my package. So I'm hiding from the documentation as well. So this is executing this code on the documentation because it's not executed by default because we don't want to see these outputs on the documentation. There's a lot of explanations about what is the French deck, how it works. It is a 52 cards split in 4 suites. It's the most common deck card you know. So this example is almost the same used by the Python Fluent code. I only changed the G key. It used strings before. It's using only integers now. And I'm exporting and I'm hiding this code on the documentation right here. So you can see the code, but it's collapsed. This right here is a callout node from the Quarto. So we are able to increment our documentation using some Quarto features. I'm going to talk about Quarto later. So this is executed on the documentation. I'm hiding them. I'm executing on the documentation. So these are the most important Nbdev calls when you're writing a Jupyter Notebooks. You're using hide to hide from the documentation, export to export your Jupyter Notebook code to your Python packages, using export I to hide from the documentation but export the code to your Python package, execdoc for execution of the documentation, code fold, the default exp to export the Nbdev file to Python files, and eval false because sometimes we're running tests on our or in our Jupyter Notebooks, and we don't want to evaluate all the tests, so we can ignore some tests like this is a test that Nbdev runs, and you can evaluate false. We're going to discuss Nbdev tests later in this tutorial, but using the keyword and some dummy tests, you can run simple tests on your cells, okay? And some projects that are used by Nbdev that build their packages using the Nbdev CLI tool is the most well-known is FastAi. Is the project that built the Nbdev tool. IPyAnnotator is the package I developed with PyLimon. We work with Nbdev since its first version. This was the documentation, the interface that it was used by Nbdev in the first version. And this is the last version of Nbdev UI. IPyAnnotator is a very visual framework for annotation, so you can annotate your data. Let me just show some example here. Nbdev is awesome when you have like this visual, you need to show something. Okay, this tutorial is better. We need to show rich elements on your documentation. So you can annotate things using IPyAnnotator, and we're using Nbdev to build our package. And this package was only be able to be developed by Nbdev, and because it runs over Jupyter Notebooks, like it's a UI that works only on Jupyter Notebooks. So Nbdev that allow us to develop IPyAnnotator. These are other awesome projects that you can search later. So what are the good practices when developing Jupyter Notebooks and using Nbdev? So it's not showing the image right here. Let me show you very quickly. When you're developing documentation for your software, there's a lot of methodologies that you can use. And the one that's recommended by Nbdev is the diataxis system. So when you're developing your documentation, you can choose what type of documentation you're developing. See if it's a tutorial that's learning oriented, or if you're explaining a concept, you're gonna create your Jupyter Notebook only to explain a concept. A reference, like you have your API, your Jupyter your package, and like my package, shuffle cards. I have a card, I have a deck, and I want to shuffle the deck. So I put this information as a reference. Like you can use this function shuffle to shuffle the deck. So it's a reference to Jupyter Notebook. And how to guide that problem-oriented Jupyter Notebooks. This is the way that Nbdev suggests you to use the diataxis system. So when you're starting a Jupyter Notebook, the best practice is, okay. What? Yeah, you have multiple methodologies to build your documentation, and the Ataxis system is a way to develop your documentation. It's not the only way, but it's recommended by Nbdev to be used this approach. No, it's like the Ataxis systems. It's a way to develop your documentation. Like it's not developed through Nbdev, or Nbdev only work with this methodology. But it's a methodology to you write your documentation. Okay? So this is something I already showed to you guys. When you're creating a Jupyter Notebooks, you want to have a good title and a good description. You can use Quarto as well. Remember, I show you the cell types on Jupyter Notebooks. Like you have Markdown and you have code, but you also have raw NB convert. This is a metadata that you can use to increment your documentation using Quarto features. So if you want to use Quarto, you can just change your cell type to raw and run Quarto commands on here. Okay. So change the text of your Jupyter Notebook according to the Ataxis system. So if you're writing a reference, you start with a small description and use symbolic symbols, because everyone is assessing your documentation to see what it can be, which features from your package is gonna be used. You can write tutorials and guides and use Jupyter Notebooks to describe what the reader will learn and be objective. And you can write explanation Jupyter Notebooks to introduce some concept for the readers. And Jupyter Notebooks are awesome because they have a very interactive and fancy way to use images, videos, audios, and use multiple visualizations. So this is awesome if you're publishing a Python package that uses visualizations. Another thing, when you're using Jupyter Notebooks, you want to keep your cells very small. So this is a cell, and you don't want to have a huge cell. And to avoid big cells, Nbdev has this feature called patches, where you can add in runtime patches to your code. For example, here I have the French deck definition. It has a lot of dundermats, Python dundermats for init, to have a size of your French deck to get a card from your French deck. But you have some additional functions like shuffle, and you can use this to avoid writing a big cell. Because previously it would be, this class would be huge with some additional functions. And using patches, you can describe and use better your Jupyter Notebooks and keep it readable. So when you're using Jupyter Notebooks, you want to import your code at the top of your Jupyter Notebook. You don't want to import and executed Python code on the same cell like this, because you're loading everything, and also running Python code is not a good practice. Avoid ambiguous execution order. So sometimes, as I said before, you can run this cell here and run this cell above, but at the end you want a sequentially executable Jupyter Notebook. Use code cells for experiment. For example, when I showed this output right here, sometimes you're running experiments on Jupyter Notebooks and you want everyone to know what what the output is, so you can execute this experimentation and show other developers, okay, this outputs this and other stuff on Jupyter Notebooks. So don't avoid code execution and output if you need it. So documentation of parameters. When you're using the data access system, sometimes you're developing the reference and you want to have documentation of the parameters you're using. So Nbdev support the two types of documentation of parameters. The first one is NumPy style. This is the classical one we're using in Python. So you have the comment of your function, the parameters, the type of the parameters, and the description of the parameters. And when you're executing your code, it will output something like this, where you have, okay, I have this function, add NP. That's some string numbers. But Nbdev also allows what they call documents. That's a way to have a very direct comments on your documentation. So it outputs the same thing, but using less code, and it's very readable. And another good practice when you're developing Jupyter Notebook, it's adding tests. So we keep the cells small, so we can run tests very specific for our features on Jupyter Notebooks. So using assert and running Nbdev test, you're able to execute the code from your Jupyter Notebook and execute the tests. So everything's passing here right now, but if I add a keyword like Nbdev is throw the error. So this is used by CI and used by your day-to-day development to run tests. And this is another exercise where we're gonna create a Jupyter Notebook on this structure that you forked, but we're gonna move on right now, and we're gonna got back to this exercise later. So here I show you the DAC definition. We have a French DAC definition, and we have the card definition. And the way this exercise would create a Jupyter Notebook card called card utils, it would export a card utils to our package. Yeah, but we're gonna ignore this for now. Let's talk about dependency hell that we were talking before. So dependency, when you're developing a Python package, you want to avoid conflicts between the dependencies of the packages. So when a software grows, they tend to add more Python packages, and they are awesome. They can add features, they can avoid and fix errors, and provide more security. But keeping them updated and moving forward with our software is tricky. So sometimes one dependency expects a certain requirement, and another dependency requires a different requirement. Like this dependency one expects Python 3.7, and dependency one expects Python 3.9. So it will have a conflict, and sometimes you need to update your package, but you can't because a package you're using doesn't allow that update. So to avoid this, you're gonna specify your dependencies. So Nbdev has that setting.ini that I showed you previously. I hope you can see. Can you see? Okay. So you can add your requirements here. So these requirements would be installed by everyone that install your packages. And the dev requirements is only for developers. So when you're specifying equals, you're fixing a certain version of the requirement you're installing. But when you're using this, you're specifying some release of the software. This you're excluding a version. This you're including a range of versions. This is the most recommended way, these two. So anyone with the black requirement from 23.1 to the next releases who can execute my code. This is a way to avoid dependency hell. So when you're creating a Python package, you're creating releases. Remember the version that we add to our software, to the minimal package we publish. So the version has a standard way to be added. It's called semantic version. It's a set of rules that help us to avoid dependency hell. So you must declare a public API, like you are having some features on your Python packages, and you need this API so everyone can work with your Python package. The version should use this format, X8Z, and should use non-negative numbers, and you're using usually this major, minor path. So our first version of the Python packages, we're using 0.0.1, right? So we don't have a stable Python packages yet. We don't have a minor update on your Python packages, and we only have a simple addition of code. So this is what we call semantic version to release packages in Python. But only releasing the Python packages is not enough, so humans can understand what was released. So always keep a file called changelog that is a semantic version, didactic way for humans to read and understand. For example, we have that first version, but we release version 0.0.2. So we're gonna add to the changelog what we did on the package and what we want to do in the future if you want to do something. So let me show you. Changelog, okay, changelog. So it uses this structure. It has a documentation site, is this one. It uses the semantic version standard and uses this markdown style where you can put unreleased features of your Jupyter package. For example, you want to add a new feature like draw a card from the deck. So you add here that next release will add this feature. And when you're releasing a new version, you're adding a date and what you did in topics usually. Okay, so we already discussed how to publish, how to load Python packages, how Nbdev exports the Python code and the HTML to the documentation. We also discussed how to create semantic version releases. Now let's talk about tools that can improve our Python package code. So Python has a lot of tools that help us to develop better Python projects. And most of them don't run over Jupyter Notebooks. But we have this package called NBQA, where you can use the most popular tools on Jupyter Notebooks. So the most popular tools used on NBQA are AutoPep 8, Black, Flake 8, MyPy, and iSort. And all of them can be executed using NBQA. MyPy is the tool that will check, it will analyze our Python code and check if it has type issues. For example, previously we usually add the NumPy style documentation, and nothing guarantees that this X and this Y would be integers. But MyPy does that if you're adding this these type annotations to your code, okay? So to run MyPy over Jupyter Notebooks, you can specify the tool using NBDev, execute your Jupyter Notebooks, and ignore missing imports from external packages. Another popular tool for quality assurance in Jupyter Notebooks is Flake 8. So sometimes you're arguing with your team about some code style on pull requests, and Flake 8 can help you to define a way to code a code style. And this discussion will be not done on pull requests again, because it's specified on autopep file on Flake 8. So Flake 8 also can check some errors, like if you import something that is not used or some typo, Flake 8 can help you with that. So it guarantees our quality assurance of the Python package we're writing. So Python has a PEP called PEP8 that defines the code style of your Python packages, of your Python code actually. And you can run using Nbdev keyway as well. Black is a more flexible way to run PEP8 on Jupyter Notebooks or Python code in general. And advanced testing. Okay, so these are the most well-known quality assurance tools. And we're gonna discuss how to use advanced testing in Jupyter Notebooks. Let me show you here. When we are using only the assert, like when we are using the assert, we don't have the isolation the test requires. So if I change the size of the deck here, like if I draw a card, it will be 51, but this test will fail. And we want to isolate these tests. In the way that we do that is using IPyTest. It's a library that allows us to run tests. PyTest, that's the most popular framework. It's the most popular framework for Python code, but it doesn't run on Jupyter Notebooks, so we can import IPyTest and runs tests on our Jupyter Notebooks. So here is that example where we can run, like we have this counter, it has an assertion and it works, but if we change here, this assertion will broke. But when we're using IPyTest, we use the magic cell IPyTest, and we can execute the code. We can guarantee that the test will be isolated from the scope of your Jupyter Notebook. So it's a great feature to have and a great way to name like what were you testing. Okay. Okay, so we discussed quality assurance tools for our Python packages. We discussed testing for our Python packages. And now, okay. Sí. Yeah, so this is a discussion from software engineering. Some people like to have the test folder separated, write tests outside of your code, but when you're using Jupyter Notebooks, you want to integrate your tests on the Jupyter Notebooks. So you keep your cells small, so you can test a very specific code of your Python package. So mixing code, test, and documentation keeps your file readable to any developers to understand what is happening. So it's also a good practice to, if you're testing something visual, output that test to the documentation. Okay. So now I think we can do one of the exercises. Okay. Let me just see, yeah. I'm gonna introduce some concepts before we do another exercise, because the idea was publish the minimal package and then publish the package that you forked from my repository. So I'm gonna introduce some concepts of CI/CD before we do that exercise. So CI/CD is a way that we integrate, like we're developing our package on our machine, on our local machine, but we want to guarantee the delivery of the software. So we increase the version and change their code, but you want to guarantee that the tests are executing and the code style is being followed. So CI/CD is a way to do that. It's called continuous integration, continuous delivery. It's a well-known concept in DevOps, but it became more accessible to developers thanks to GitHub Actions and other tools. So it automates some stages of the app development. It enforces security when we're delivering new versions of the Python packages. So you may not be able to see the image, but you have the CI and the CD. You're building your package on the CI. You're testing your code on the CI, and you're merging your version, like you're merging the release on your main branch. This will automatically release, and a release for Python packages is creating a new release on PyPI or test PyPI that will be automatically deployed, like it will upload our documentation to GitHub pages or some other place. Some tools that we can run CI/CD are GitHub Actions, GitLab CI/CD, Jenkins, CircleCI. And we're using GitHub Actions because it's easy to use, it's free until 2,000 minutes, and it's very easy to use. Most tools have some integration with it, and Nbdev also have integrations with GitHub Actions. The core concepts of a GitHub Action is these 4 events: jobs, actions, and runner. So when you're creating a commit to your GitHub account, it's dispatching an event. It's triggering an event. So this event can be listed and executed by a sequence of steps that's called jobs. So, for example, we're releasing our package to the 2nd version, or it will be listed as an event. It will execute the jobs that will run the tests, the quality assurance tools, and it will publish our package on test.py, and it will publish our documentation. Another concept from GitHub Actions are the action itself. It's a way to avoid developing lots of code in GitHub Actions files. Let me show you real quickly here. So you develop GitHub Actions in this GitHub file, in this workflow subfolder. And for example, you have this publish file. So we have the name. It will listen to releases. So every time I release a package, it will be published at the test.py. This is something that we did manually, but now it can run automatically every time we release on GitHub. So it will run all these steps, and it uses this action to set up Python. So install Python on your GitHub action is a very common feature that we need. So the Python organization can create an action, and you can just reuse the code. This is what actions is. And runner is the server, is the GitHub server that executed the workflows. So here in this project, I created 4 workflows, one for publishing in TestPI, another for checking QA, the quality assurance of our Python packages, running, I think it was MyPy, Flake 8 on the Jupyter Notebooks. It will deploy the pages to GitHub pages, and it will also run. So it listens every time I made a commit or pull request or push anything to GitHub, the test it will be executed. Okay. So I think before advancing, it will be nice to. This is why we forked the project. It's to publish that code on our test.py account. So let's back to the exercise. I think maybe we have time. It needs to be quickly. Let me search. So in the forked folder that you made, you can access there and create a new virtual environment for that using Python /m/vm, the tutorial name. Can you see, you guys? Okay. So you can access the fork, you can clone the fork you made and create a virtual environment there. So you can come here and clone your fork, right? Like go to someplace else and clone your fork. To clone your fork, you can access here the fork that you made and just copy the HTTPS or SSH and clone on your terminal. Yeah, you're already cloned. You already cloned your fork on your machine. So now you create a virtual environment, a new virtual environment, and activate it. Okay. So this is the sequentially steps that we need to make to install the dependencies, pip install dot and this command right here to install the development tools. But if you're on a Windows machine, the README also has all packages listed as a pip install, okay? So you can also run this instead of this. Guys, so when you're renaming your package on Windows machines, you're running on some issues. I'm not sure why. On Linux, it works well, but it may be the different file. I don't know, because I wrote on a Linux file, Microsoft's not reading the file. I create this script because it's like very painful to change the name of the package because you need to change all imports on every Jupyter Notebooks. For example, I'm using here, like the name of my package is Ítalo Epifânio deck, and you need to change everything here. But if you're not able to accomplish that, we're gonna move on from this exercise because you need to change everything with your username deck on every Jupyter Notebook. You need to change this folder for your username as well. So So I think we're gonna move on from the exercise and got back to the theory of the Nbdev. I was not expecting this problem. Sorry. So the idea was to rename your Nbdev project and upload using GitHub Actions. You can see GitHub Actions being executed on your repository. When you have it set up, you can go here to Actions, and you're gonna be able to see that every time I commit or merge something on my code, it will run a pages build deployment, a linked execution, deploy to GitHub pages, and tests. I'm gonna update my script later to fix this bug so everyone can do this exercise. The idea was to publish this this documentation on your GitHub account. That's why we forked the repository. Sorry about that. Let's move on with the theory behind Nbdev. What? So let's move on from the exercise since it has some problems with the Windows machines. To upload anything to the PyPI using Nbdev, you can use Nbdev PyPI, Nbdev Conda, and Nbdev release both to publish on Conda on PyPI. And if you're using test PyPI like we are, you can just add the repository to upload this code to your test PyPI account. If you don't like to put your password and username every time you're uploading something to test PyPI or PyPI, you can write your password to PyPI-rc. It's a file that Python reads globally. But it's not recommended to add your username and password to that file. Usually, we first upload the package manually, like we did before, and then we go to test PyPI UI and create a token for our project. So, and then we rename the PyPI-rc file. And if you're using other repositories than PyPI or test PyPI, you can create this private repository on the PyRC file and put the URL of the repository there. Remember,
What is a good example of private repository?
You can use a GitLab, or you can use the AWS. AWS has a private repository, so you can use one of them. Yeah. So I already show you the workflows. So if you have your Nbdev installed and running on your machine, you're gonna be able to go to change. If you're already uploaded your forked repository to your test PyPI, you will be able to create a token for your test PyPI package. But since we were not able to do that, I will move on. But GitHub has a way to keep tokens from like hiding the tokens from other people. It's called GitHub Secrets. So when you go into the interface of GitHub, you can go to settings. test API. So there's an option here in GitHub where you can add, but I think it changes the interface. I'm a beta user from GitHub, so it may change the interface. Like here is beta, maybe they change something. But when you're going to your GitHub repository, you can go to Settings, Actions, and add a GitHub secret that's called test API token, so you can upload your project using CI/CD in your GitHub project. And to publish, you upgrade the version on your settings.ini, update your changelog, commit and push your change to GitHub, check if the tests and links are passing, and then create a release using semantic version, the semantic version standard, and we will be able to upload your package with all those automations that we talked about before. So going back to the end of the presentation, I'm going to talk about Python packaging history. So the first version of Python, you were not able to install Python packages. It didn't have a package manager. But in Python 1.6, Python introduced the setup.py, so it's a very old approach of installing and using Python packages, writing setup.py files. It was added, and this utils package manager was added to the language as well, but it didn't install the requirements of that package. So people created a package and said, on the documentation, install those packages to use my package. So setup tools was introduced to fix this problem in 2003. In 2004, easy install was added to be used alongside setup tools. In 2008, PyPA, Python Packaging Authority, was founded because everyone says that Python has a problem with Python packaging. It's like not other languages has better package management. So to fix that, Python created in 2008 this authority to regulate the packaging. And in 2011, pip became the default manager. That's the one we use today. The wheel package was introduced. It's a way to distribute binary Python files. It's very fast to install. But when you generate a wheel package, it's generated for architecture. So if you're running on Mac, it will work only for Mac files or Mac computers. If you're generate on Linux, it will work only for Linux machines. In 2017, the Fleet package was developed and introduced the pyproject.tom. That's the modern way to write metadata. So all those metadata, name, version, description, your author, your license, are now added to pyproject.tom. This change was made in 2020. Is more the modern way to do it, but Nbdev still didn't add to its core. Like there's an issue and there's a pull request there, but it still doesn't work with PyProject. So what is Quarto and how to style your documentation using Quarto? Let me show here Quarto. So Quarto.org, as we're discussing, is not a Python project. You're not installing a Python project, you're installing an R project. It's from R Studio, and it's a way to write technical stuff using Markdown or Jupyter Notebooks. So you can write Python or Julia and this JavaScript plugin called Observable to create websites, to create blogs, HTML, PDF documents. it's a great way if you have a research and like to publish that to other people, you can use Quarto, and that's why Nbdev is using Quarto. It was introduced in the second version of Nbdev. The first version was not using Quarto, and it had a lot of issues with the generation of the documentation before. So Quarto helped a lot with different tools and different customizations. Like when you generate a Quarto, like you're running Quarto preview, your documentation will be executed in a random port and will open a browser. So I always change the way that Quarto will open the Nbdev documentation. You can change the navigation of your GitHub pages. So I can put pages here or pages here. I can change the navigation of my documentation using Quarto. You can add Google Analytics to your GitHub pages if you're publishing Nbdev. So there's multiple features like dark mode, page navigation. For example, in my project, I'm not using page navigation, so you can't navigate from deck to hand. Like there's no next page here. But if you're activating, you can add this feature to your documentation. There's reader mode as well. And this is a part of the tutorial. I want to show some cool features of Jupyter Notebooks that are further than Python packaging. The first one is using Voila. Voila it's a package, a Python package that allows us to use our Jupyter Notebook as a dashboard. So I publish a minigame using I create a minigame using the French deck. The French deck that I showed you before, that French deck definition. And Voila allows us to execute the Jupyter Notebook as an application. It's a Jupyter Notebook execution, so it renders all Markdown. And this is the UI I developed. So the cards are represented by buttons. So this is a button. And in the Jupyter Notebook, you're going to be able to see the code, but this is only the UI that we created. And this is the game. So you can push the cards, and if you reach 21, you win, and if otherwise, your game is over. So this is a simple application of Jupyter Notebooks for using Voila, but most people use Voila to create dashboards. So if you're a data scientist, you can create fancy dashboards and show to people. It has data, it has access control. So if you need to create users for your clients, you can create them and share with them. So it's a very clever way to share Jupyter Notebooks and data science applications. And okay. Okay, good question. This was running Python code. So there's a trend on Python ecosystem that, like, you already have a lot of knowledge in Python and data science. You don't need to understand JavaScript. So first they create PyScript, right? So it was a huge creation, and the whole community was talking about. But there's some other tools, and here I'm using IPy that we can create interface using only Python. So I can show you the code right here. IPy widgets are the most basic library that creates UI for Jupyter Notebooks. There are other UIs that create fancy interfaces for you. So this is very simple. This is the most basic tool. But with that, you can create, for example, here's the button that I was talking about, like the test button. I'm just calling a widgets button, say that it will be disabled, and it will have a description and a layout. So it will be increased by its name. So it's that library that I showed you before called IPy Annotator is all developed using IPy widgets. We develop annotation for machine learning data using IPy widgets. And we use Voila for our annotators to use the interface. So yeah, you don't need to understand JavaScript to build interfaces, and you can create them on Jupyter Notebooks. That's the cool part of working with this. And the last part is new too. There's multiple ways now, I think. When I create this presentation, there's a way to use ChatGPT on your Jupyter Notebook that I'm gonna show you. But now there's more fancy plugins that you can install and use. So Jupyter Notebook doesn't have like GitHub Copilot, right? That can help you, but you can install this package called SKAI, and you can ask ChatGPT to help you with your tasks using Jupyter Notebook. So I'm gonna show you right here how it works. This command will install the package. This will load your OpenAI key. You can open your OpenAI account and get a key from there. This is gonna load the package on your Jupyter Notebook, and this is how you use. You can ask something to your ChatGPT. It will take a time, but you answer. So here I ask for a French deck definition, that class that I showed you before. This code is the code from the Fluent Python. So it uses unit code here instead of strings, and uses the strings. I only changed to integers because it was easier to my example of that game. It was easier to use. So that's all I prepare. I'm sorry for the exercises. I'm gonna share the PDF with you guys on the repository. Right now you already have the presentation on your fork. Let me show you here. Sure.
So you will be using the patch in your notebook. Does the patch need to be right behind the class, or should be in place?
I'm not sure if I understood your question.
If you go back to your example
In the ChatGPT?
when you added the add patch,
The patch. In the slides, in Jupyter Notebook, where?
yes, in the notebook,
In the notebook? Which one?
it's probably a couple of slides back.
Oh. Is
Curious when you add that we use the add patch.
this is
Does it now actually, the previous, it should be added to the previous class or the previous piece of code? Does it need to be right below or?
so? Remember I said that uses sys.path. So when you're using the Python interpreter, he will search on that sys.path. And when you're appending,
No, I don't think we're talking about add batch. Add batch? Yeah, if you when you add with the grader. Oh, okay. The grader, not the batch. Oh, okay.
let me show. So when I have the decorated patch, what's your question?
Yeah, so this needs to be right behind the first row. If you have multiple classes,
Yeah, so when you're writing here the self, you can mention the class that will be patched. So it will patch using this.
okay, so it gets the class with, okay.
Yeah.
The class limit.
Yeah. You have a question as well? Okay. So where was that? So, okay, this is the repository. You have the presentation right here. I developed the presentation using Quarto, so it's a KMD file, like it's our application, so it uses this format. It's Quarto Markdown. To develop presentations with Quarto, you just need to add a title to your presentation. Every Markdown title, it will be a new slide, okay? So to run this, you only have to run Quarto preview presentation index, but I will also add the PDF to the GitHub so you can access later. The problem with the script, the renaming script, I will fix it, and I will probably upload a video to finish the exercise that we should have done in this tutorial. You guys have any questions? Okay, so I'm gonna conclude here. Okay. This is a good question. I don't know a way to do that because unless you're calling a lot of sub-processes using Python code to call your C++ code, I'm not sure how you would do that, at least with RStudio or Jupyter Notebooks. Only if I think C++ has something similar to Jupyter Notebooks. Yeah, I think I read something about it, but it's very alpha release. No, it's not used. Let me run my presentation here and conclude. So Quarto presentation also allows you to run Python code and other stuff. That's why I developed using Quarto presentation. So Jupyter Notebooks is awesome for quick prototyping. Code, docs, and tests can be used to tell a story with your code, to tell a story of your code and improve the documentation. This is something that I always iterate with my team. For example, if I have a code that the team didn't understand on my pull request, I go back to my documentation and update there, adding to the Jupyter Notebook. So I always tell a story of that package. For example, there's a workaround or I install a specific version of the software. I'm always iterating over the Jupyter Notebooks. Jupyter Notebooks itself doesn't allow you to write literate programming because it doesn't write the documentation and the code, it doesn't split both. But with Nbdev, it allows to use this paradigm. Publishing a package with Nbdev is easier, faster, and efficient. And visual libraries benefit a lot from Nbdev. So I'm from Brazil and I work for Pylimon, that's a company for Germany. And we have a 4 hours time difference. So we work completely asynchronously. And the tool that allows us to work asynchronously is Nbdev, because I'm always iterating and documenting everything that we discuss over text. So that's the way we work. And that's why Nbdev is so important for us. And as I said before in the introduction of the presentation, Nbdev got into a GitHub program that will accelerate its development. So it will get huge and I hope you will be soon using Nbdev. So that's the presentation. Sorry for the problems we have, but I will fix it. I will send an email for everyone with the link and the fixed for Windows machines. Okay. So thank you.